All right, so welcome to today's tutorial. We're going to be revising quadratic functions according to your request. You said we should look at uh, quadratic functions and how to find the domain and the range of any given function. So, so uh, so what is important here when you're finding the what's this the quadratic I mean the when you want to sketch the graph of any given quadratic function, the most important thing that you need to know is how to find the turning point, how to find the minimum and the maximum value, and how to find the axis of symmetry. Yeah, so another important part of sketching the graphs is how to know the kind of roots that a given quadratic function has. So the roots are the ones that are going to tell you the x-intercepts. The roots are normally the x-intercepts. So here we're going to start first by solving these questions, which are telling us to determine the kind of roots that A and B has. So when you want to find the kind of roots that any given quadratic function has, you first have to, you first have to use what is called the discriminant. So the discriminant is just found under the root when you're finding the, okay, when you're solving a quadratic function, you use this formula, which is negative b plus or minus the square root plus or minus the square root of b squared minus 4ac, then everything over 2. So what the discriminant is simply just the. Yeah. Okay. Let me just mute everyone. I don't know what is happening. Okay. Yeah. So saying the discriminant is simply just the what's this b squared minus 4ac, which is under the square root. So what is important again here is let me do this first. Okay. So what is important here is for you to know what kind of roots that a given quadratic function has, and how can you know that it's yeah, and how can you know that it's by using the discriminant. Yeah, sorry, I just got disturbed a bit by something. All right, let's now continue. So the discriminant is given by b squared minus 4ac. Yeah, so the discriminant is given by b squared minus 4ac. So you need also to know which one is your a in this given quadratic expression, which one is your b, and which one is your c. So a is the coefficient of x squared, b is the coefficient of x, and then c is just a constant. So there are simply about, is it 3 conditions? Yeah, about 3 conditions that are going to tell you whether the given quadratic function has real roots, imaginary roots, or complex roots, or if not complex or imaginary or not real roots, then it will have real roots. Okay, so if your D, for instance, so if you find D and then you discover that your D, so if you find D, then you discover that your D is greater than 0, So if you find D and then you discover that your D is greater than the 0, then just know to say that given quadratic equation has real roots. And then what happens if the given quadratic equation has real roots? It means that it's going to cut the x-axis at 2 given points. If it has real roots, then it's going to cut the x-axis at 2 given points. What do I mean? It can either be like this, or it can either be like this. If it's like this, then it's cutting the x-axis at 2 points, this one and that point. And then if it has a minimum value, then it's cutting the x-axis at that point or that point. Yeah, hope you are understanding. So I want to make you know the basic things about sketching these things, the quadratic equation, and then sketching the quadratic functions. And then if D is less than 0, it means that it has no real roots. No real roots. And then what happens if the given quadratic expression has no real roots? What happens, or what does it mean? It means that a given expression, a given quadratic expression does not cut the x-axis at any point, meaning it can either be like this, it can have a minimum value which is like that, or it can be like that. It can be, if not that, it can be like that or like that. As long as it's not cutting the x-axis at any point, then know to say it has no real roots. In other words, it has imaginary roots. Yeah, or complex roots. So let's look at the other what's this? The other condition. So if D is now equal to 0, what happens? This one we say it has equal roots or coincident roots. So it has equal roots. So now what does it mean when we say the given expression has equal roots? It means that it cuts the x-axis, rather it touches the x-axis at one point, meaning it would just be like this, meaning the turning point is exactly at the x-axis. It can either be like that, or it can be a maximum, meaning it's going to be like that. It will touch the x-axis at the turning point. So when the given graph has equal roots, it means that it's cutting the x-axis at the turning point. All right. And now, how do you know to say it's a minimum or it's maximum? I'm going to tell you when we begin to sketch, or maybe let me just say it here so that at least when we go to the sketchings there, you are just going to be looking at the expressions and know to say it's minimum. So when the value of a, meaning the coefficient of x squared, is less than 0, then sorry, when it's greater than 0, then it is a minimum. So when it's greater than 0, then it is a minimum, meaning it's going to face up. So when it is less than 0, when a is less than 0, then it's a maximum. So meaning when the coefficient of x squared here is positive, then it's a minimum. When it's negative, if we had a negative here, would have said this quadratic expression has a maximum value. So let's quickly move on now to finding the roots, the type of roots that these two quadratic expressions have. So here we're going to say we're going to find D, and D is going to tell us whether the given roots here are are coincident or equal, or they are imaginary, or if not imaginary, or the given expression has real roots. So D is equal to B squared minus 4AC. So the value of D here, the value of D is equal to B squared. B squared, on B here, the coefficient of X is -1. So we're going to say -1 squared minus 4, and then A is equal to 2. And then our C is simply the constant, which is 5. So now we find D. So 1 squared will give you 1. I mean, -1 squared will give you 1, and then minus 4 times 2, you get 8, times 5, you get 40. Like that. Yeah, you get 40. So when you subtract that, you discover that this will give you 1 minus 4 to give you -39. And we know to say -39 is -39 is less than 0. Or let me write it this way. So D is equal to -39. And we know to say, we can now conclude to say, since D is less than 0, meaning it has imaginary roots. Why do we say it has imaginary roots? You guys, you have to be understanding these things. Don't just master to say imaginary or complex roots. No, you need to know. This D always comes from, let me write this quadratic formula here. It's like this. So this D always comes from under, there was this, the square root, like that. So this D comes out of the square root, like that. So meaning, if we have a negative number outside the, inside the square root, imagine that we have, let me just write it properly here. Imagine that we have the square root of -39. What is the square root of -39? At your level, you are going to say, this one is math error. It doesn't exist. But when you learn complex numbers, you're going to agree with me to say the square root of -39 is a complex number. The square root of -39, since I can't find that using my own head, I mean, I can only use a calculator to find the root of 39. So I'm just going to write 39 like that, and I'll make sure that I put I outside. So the square root of 39i is equal to the square root of -39. So you're going to learn this very soon when you start complex numbers. So our conclusion on the first question there is that this given quadratic expression has no real roots, or in other words, it has imaginary or complex roots. Let's also test B. So B here, we also use the same formula for discriminant. Yeah, so D is equal to B squared. On B, we have 4. So it's 4 squared minus 4. And then my A is 1. And then my C is -2. So D is equal to, this will give me 16 minus 4 minus 2. -4 times -2. Oh, let me just say, -4 times -2, I'll get a positive number there, and then I'll get 8 there. So here it's just a matter of adding this. So 16 plus 8 will give us 24. So since D is positive, this is 24. Let me write it properly. Okay. So since D is positive, then D is greater than 0. So when D is greater than 0, we conclude to say this given expression has real roots. So when it has, so if it has real roots, then you can conclude to say it cuts the x-axis at two different points. Yeah, two distinct points. So this is how you know the kind of roots that a given quadratic function has. So let's quickly move on to the next question. We see what we have. So our next question here, this is what you were waiting for, you guys. This is what you wanted. You wanted to know how to sketch the graphs. And the question says, complete the square of each of the following quadratic functions. Hence, sketch the graph of the functions showing clearly the x and the y-intercepts and the turning point. And then the first question is telling us to find the line of symmetry. And then the second question is telling us to find the maximum and the minimum value of the function. So the first thing that we have to start with here is by completing the square. Is completing the square of our functions here, the functions that we've been given. So you guys should pay particular attention on how I'm going to be completing the square of these functions, because I've observed the exercises that I've been giving you, a few have been getting these questions correct. You may know how to sketch the graphs, you may know how to do everything, but if you don't know how to complete the square, it's just the same as a person who knows nothing. Because completing the square is like the first step of doing everything. So if you can't complete the square, I'll show you another method in which you can, the other method that you can use to sketch without completing the square. Yeah. Just in case in the exam, they just bring a question to say sketch without telling you to say complete the square. I may also show you. It's straightforward and it's simple. But here, let me show you the recommended method of doing this. So, okay, so we begin. Here, they have told us to complete the square of this function. So how do we do that? So we have our f of x in that manner. Then we have 2x there, 2x squared minus 4x, and then plus 5. So what you do here first, you factor out the 2. So when you factor out the 2, you are going to have x squared minus 2x. So follow these steps properly and clearly. And then you write your positive 5 outside. Now, most of you, what you do from here, you just go directly and divide by 2. No, that's not how you do that. If we had an expression which was like this, yeah, this is x squared. If we had an expression like this, if the expression was like this, and then they say it's equal to 0. So for this one, it's not wrong when you divide everything by 2 when you want to start completing the square, because you know that even this 0, you divide it by 2 and it will give you 0. But this side, if you divide everything this side by 2, it means that even this side you have to divide by 2. That's the way it is. Because for this expression to be called a quadratic equation, there's this word at the end, which is equation. Equation simply means they are equal, meaning whatever you do on one side of the equal sign, you also have to do it on the other side. So if I divide everything this side by 2, meaning even this side I have to divide by 2. But since this side there is a variable, there's just something which is a placeholder. There's a variable, there's f of x. It's telling us to say it's a function, meaning you don't have to divide by 2. What you need to do is to factor out the 2. So once you factor out the 2 like that, the next step will now be you completing the square of what is in between there. So I'm going to write my 2 there, and I'll maintain the square brackets. And then what I'll do is I'm going to write my x squared there, and then I'll write my negative 2x there, and then I'll write minus, I'll write plus, and then I'll open the brackets. So what I'll write here in the brackets is half of negative 2. What is half of negative 2? Half of negative 2 is negative 1. I'll write it like that, and I'll square. And then I'll subtract this same thing again, which is negative 1 squared. And then I'll close the brackets, and then I'll write my 5 outside like that. So what you do here, or the main thing here, or what I've done here, I've done nothing to this equation. I've not changed anything, because when you subtract this, when you subtract this from that, you get a 0, which implies that you are just going to go back to what is here. Okay. So we can now complete the square. So I'll write my 2 outside like that, and then I'll open the brackets. So I'll get rid of this negative 2x. How? By combining x squared and negative 1. So I'm going to combine x and negative 1, and then I'll square everything. So meaning I've gotten rid of this negative 2, and then I'm going to have my negative. This negative is the one that I've written here, and then this negative 1 squared, when we solve that, negative 1 to the power 2 will give you positive 1, and then you close the brackets like that, and then you write your 5 outside like that. And then what follows now will be opening the brackets. You multiply these 2 times this in the brackets there, you have 2, and then open the brackets, you have x minus 1 squared, and then minus 2 times 1, you get 2, and then you write your positive 5 outside like that. And then what you do next here is you just simplify it. Now we are almost done with the question. We just simplify it. So negative 2 plus 5 there, it will give you positive 3. So this is basically how you complete the square of any given function. Now you guys, I don't know how you do these things and where you get some numbers. I get confused even when marking. This is how you do this. It's just as simple as this. So we now go into finding the, okay. So the y-intercept is just simply equal to this 5 here. That's the y-intercept. So meaning the curve is going to cut the y-axis at positive 5. In other words, when you are sketching the curve like this, since it's a minimum, so it's going to be like this. When it comes out like this, meaning this part here where it's cutting the y-intercept, where it's cutting the y-axis is the one that we call the y-intercept. So we have found the y-intercept. Here we're just remaining to find the x-intercept. How do you find the x-intercept now? You find the x-intercept in a similar way. How? By equating this, or rather by just solving this quadratic function. If you don't want to start resolving this quadratic function, you just equate this given expression here after that you have found after completing the square, you equate it to 0. So when you equate that to 0, you're going to have 2x minus 1, and then you squared plus 3 being equal to 0. I think I solved this question some time back. I remember it gave us something like an error. I think there was a mistake somewhere. But either way, let me show you where the error is. So when you take this to the other side of the equal sign, when you take this 3, positive 3 to the other side of the equal sign, you're going to have something like this: x minus 1 squared being equal to negative 3 over 2. So here, to get rid of the squared, you find the square root this side, even that side. So we're going to remain with x minus 1 being equal to the square root of a negative number gives us what? A complex number. Sorry, this is 2. So the square root of a negative number gives us a complex number. So meaning it's nearly impossible for us to sketch this graph. Yes, I think there was an error. There was just a problem somewhere. So somehow, if you test this expression by using its discriminant, you discover to say this has no real roots, meaning it does not cut the x-axis at any point. Sorry, I said at one point I said it's nearly impossible. No, it's possible for you to sketch this graph, but since it has given us an imaginary part this side, meaning it has no x-intercepts. So since it has no x-intercepts, it means that it does not cut the x-axis at any point. Hope you have gotten me clear. Let us now sketch. Since it has no x-intercept, it has given us imaginary numbers here, this side. So meaning that it does not cut the x-axis at any point. So meaning it only has a y-intercept and not not x-intercept. So if we are to sketch that given quadratic expression, this is how it's going to come out like. Okay, so what will be our turning point? Our turning point, so here I'm just doing a rough sketch. For you, you have to indicate the x there, the y this side. Yeah, you have to show clearly that it's an x or y plane. So the turning point is just 1, 3. So if my turning point is going to be 1, so I'm going to put 1 there. And then 3, I'll just do this. And then I'll do that 1, 2, and then 3 like that. So my turning point will be somewhere there. And then when you look at the value of A there, the value of A is greater than 0, meaning it's a minimum, meaning it's a maximum. Oh, sorry, it's a minimum. Since the value of A is greater than 0, then it is what's this? A minimum. So meaning it's going to go up. Let me just erase this. If it's a minimum, it means that it's going to face up. Okay. So we have 1, 2. So this is where my 5 is. So this 5 is my y-intercept. So that's where it's going to cut the y-axis from. So it's going to come out like that. It will cut the y-axis at 5, and then it will make a corner, or it will turn at 1, 3, like that. So this is basically how it's going to be when you sketch it. So sketching such graphs is very simple, as you have just seen here. Without stressing, we have finished sketching it. The reason why it had given us imaginary roots, it's because it does not cut the x-axis at any point. All right. So now, yeah, it does not cut the x-axis at any point. Yeah. All right. So we proceed. We move on to the next question. We hope that this one is going to cut the x-axis. All right. So we start this one again, completing the square of that. So for this one, there's no need of dividing by anything because our coefficient of x squared there is 1. So what you just do is you just go directly into dividing this, or you just, we say x squared, we have plus 2x there. And then you write the half of 2 is, so I'll say plus, the half of 2 is 1. So I'm going to write 1 in brackets and then I'll square it. Then I'm going to say minus this same one again. I'll square it and then I'm going to write minus 5 there. And then here now I complete the square. How? By combining x squared and 1 squared. So I'm going to say x positive 1 and then I'll put them in brackets and then I'll say squared. And then I'll write this minus 1. Minus 1 squared is 1 and then this is negative 5. So here it's just a matter of just simplifying the expression. So meaning we have 1 plus x, x plus 1 squared, and then negative 1 minus 5, you get negative 6 there. So here we can now proceed. We find the line of symmetry. So to find the line of symmetry, you just equate what is in the brackets there to 0. So you're going to have x plus 1 being equal to 0, meaning the value of x will be equal to negative 1. And then we find what's this? So this is the line of symmetry, and this is the value of x at the turning point. Sorry, in the previous sketch, I forgot to indicate the line of symmetry on the sketch, but for this one, I'm going to indicate. So the line of symmetry is basically a line that cuts the given graph or sketch into 2 equal parts. So we also now find the minimum or the maximum value. So when you look at the coefficient of x squared there, it's greater than 1, meaning it's a minimum also. So now, since it's a minimum value, how now can you find it? Simple. You just get what is outside there. So what is outside is negative 6, meaning my minimum value will be equal to, so since this is a value, yeah, so my minimum value will be equal to, yeah, it should be negative 6. Yeah, should be negative 6. Let me just research more about this one, but I think it should be a positive of this, meaning it's the absolute value of negative 6, meaning it should be positive 6. Okay, I'll get back to you in the group once I do a little bit of some research, but I think the value, this value is negative 6. And then if they said find the minimum or the maximum point, meaning that would be a turning point. The minimum or the maximum point is simply just the turning point. In other words, actually it has even been asked here that we should find the turning point. So the turning point is now found by just getting this. So the turning point is found by, in other words, it's just by equating what is in the brackets there to 0 and then find the value of x. So meaning it's negative 1, comma, what is outside there, which is negative 6. So negative 1, comma, negative 6 is the turning point. So let us now quickly move on to finding the x and the y-intercept. So the y-intercept, like I said, you just get the constant. So the constant here is negative 5, meaning it's going to cut the value, it's going to cut the y-axis at negative 5. Now, how do you find the x-intercepts? So the x-intercepts, you equate what you've been given here to 0. What you have found here after completing the square, you equate it to 0. So I'm going to equate, let me just write it on top. So I'm going to equate my x plus 1 minus 6 to 0. I've just equated this to 0, this part here. I've just equated it to 0. And then I'll take this 6 to the other side of the equal sign. And then it will be something like this. Positive 6 this side. So when I make x the subject of the formula, I'm going to have something like this. When you square both sides of the equal sign, or let me just do it step by step for the sake of everyone to understand. I wanted to skip some steps. So it's going to be like this. So when I square this side, I also square this side. So this square root always moves with a plus or minus. So I'm going to remain with x plus 1 this side, and then this other side I will be having plus or minus the root of 6. And then I'll take this one to the other side of the equal sign, meaning it's going to be -1 plus or minus the root of 6. Now, how do you sketch such a what's this, a point on a graph? Or in other words, let me say this: the x-intercepts. Let me make this point clear. The x-intercepts will now be equal to, our first point will be x being equal to -1 minus the root of 6. This is a number. And then our other value of x will just be equal to -1 and then plus the root of 6. The first one was -1 minus the root of 6. The second one will be -1 plus 6. I've just separated this -1 plus or minus 6. So these are the x and y intercepts. So now let's quickly move on to sketching the graphs. So sketching the graph will now be like this. So I'm just going to write 3 there. This is -3, and I'll write my -6 there. And then this side I'll write -1, and then I'll write negative. Okay, let me just do this before I write the values of x. So let us now sketch this. So our turning point is -1, -6. So my turning point will be here. And then I've been told, according to this, since a is greater than 0, meaning it has a minimum value. Since a is greater than 0, meaning it has a minimum value. So if it has a minimum value, meaning it has to come out like this. So let me now, okay, let me just do this. Since a is greater than 0, then the graph is going to come out like that. So now, let's quickly now sketch this graph. So this is my turning point, and then my y-intercept is -5. So my y-intercept, I'll write it maybe somewhere there, -5. So I'm going to sketch my graph. It will cut the y-axis at -5. It will go up like that, and then to cut the x-axis at the x-intercept. So at this point, this is where my -1 minus the root of 6 is. And then at this other point, this is where my -1 plus the root of 6 is. So this is basically how you do your sketching. And then after sketching, it's important sometimes to also show to say, what I've sketched is fx being equal to, you write your expression this side, x squared, then you write everything plus 2x, yeah, plus 2x, then you have -5 at the end, you finish it up. Okay, so basically this is how you do your sketching. And then I don't know what I've left here. I said I'm also going to put the line of symmetry. On the previous question, I forgot to indicate this line of symmetry. So how do you indicate that? You just draw, you can just draw a dotted line there, like that. And then this dotted line, you just name it to say this one is x is equal to -1. So this is our line of symmetry. As you can see, it's dividing our sketch or our curve into 2 equal parts. So I think we have found everything that we are supposed to find. We have even sketched the graphs. So instead of me maybe going to solve these other questions here, let me first entertain questions. So if you have any question about what we have solved, because I wanted to start solving these other two questions, but I've discovered that whatever that we have done in this question is basically what we're going to do on the other two questions. So if you have any questions, please ask. This is the right time for you to ask, because most of you are saying, no, I want to know how to do, yeah, I've forgotten something, to find the domain and the range. I'm going to show you. And then apart from that, let me also maybe explain this. Okay, so this, if you have, for instance, okay, let me do this. I'll demarcate here. If you sketch your graph, it comes out like the way the previous one has just come out. It came out like this. So if, for instance, these are your x-intercepts. Yeah, these are your x-intercepts. And then, yeah, this is your y-intercept like that. And then this is your turning point. And then you've been told to say, this now has its absolute value like that. It's going to have, you're going to have your absolute, you have your maybe x squared. And then let me just write it properly. You have x squared like that in absolute value symbols. You have x squared plus 2x minus 5. So if you have this, and then you've been told to sketch it, if your graph is supposed to come out like that, it will not come out like that because of these absolute value symbols. Now, how is it going to come out? So this is how it's going to look. So instead of it coming out like this, let me just change the color of the pointer. Let me use maybe black. Okay. So if it was supposed to come out like this, like the way it came out, it's going to be like that. It will come out the way it's coming like this. But instead of going to the negative, since the absolute value symbol implies that we have the probability of us getting the negative number after solving this is 0. So meaning we will not have any negative answers or any negative region after sketching the graph. Hence, we will not proceed going down, but it will bounce and begin to go up like that, and it will come down like that. And then after it reaches that side, it will now go up again like that. So this now becomes our turning point. So since our turning point was -1, -6, it will now be equal to -1, +6. So this is now going to be our turning point. And then our y-intercept here, if you remember, it was -5. So now it will change, it will be positive. Yeah, it will be positive. I think instead of it being -5, I think it will be +5. Yeah, it will be +5. Since we're now just dealing with positive numbers. Yes, so now the question is, how do you find the domain and the range of a given function? So I've explained on the absolute values. Now let's look at the domain and the range. So when you're finding, if you've been told to find the domain and the range of a given function, after sketching the graph, for instance, you can ask yourself to say, is there a way I can make this function undefined? This is the question. Every time you've been asked to find the domain and the range, the first thing when you want to find the domain, you ask yourself, is there a way in which I can make my given function undefined? So if there is no way that you can make a given function undefined, then the domain will now just be equal to -infinity to +infinity. Or in other words, you can just say it is the set of all real numbers. So meaning you just write your arrow that side. So it's the set of all real numbers. That's a domain. And then how do you find the range? So the range is simple. The range, you just look at the minimum value here. So the minimum value here you can see is -6. So meaning our range will start from -6 going to positive infinity. So our range will start from -6 going to positive infinity because our curve is facing up. If it was facing down, would have said it's going to the negative infinity. So this -6 is also part of our what's this, so meaning you also include it. How do you include it? By changing this bracket, you use this one. So please, if you have any questions, you can ask. I think explained everything. If you have any question, you can ask. Questions, please. Questions, if you have any questions, please ask. Okay. Silence is also a language. It's telling me to say, you guys have understood. And I think I'm going to send the recorded video together with that one which just cut due to network challenges. So I'm going to send both of them. I'm going to combine them and then I'll send them to you guys so that you have time to go through them on your own. If you have any questions, you can inbox me. I'll respond to you. All right, thank you very much for watching today's tutorial. So if there's also another part where you need revision, you can also suggest in your group to say, guys, can we revise about this? And then I'll be there, I'm going to teach you. Yeah, so for me, I'm going to be getting your views from you. Yeah, once you say we revise on this topic, I go back, we revise, we forget. Yeah, so because it's not nice for us to be just going forward, you're just moving without you guys understanding. I'm there for you guys to understand what you missed, what you did not understand in your lecture, in class. All right, thank you very much for watching today's tutorial. So see you in the next lecture that we're going to have, which is tomorrow, around the same time. Shalom, shalom.